Hey everyone, Mr. Newman here, and I'm going to show you guys how to do 3 problems from a worksheet that I shared with you guys. This will be problems number 5, 7, and 11, and I picked them out for different reasons, and I'll share why with each one. I picked up number 5 because that seemed to me to be the first one that you guys might trip up on. It seems a little different and a little new, and honestly, when you first look at this, it might be a little difficult to tell which side you might even want to start with because they both seem kind of complicated. I started with the left side. And there's a little trick I used in the middle here to help you see this. First thing I actually noticed and I saw was this 1 plus tangent squared of x on the top. That kind of rang a little bell in the back of my mind going, hey, that looks like one of the Pythagorean identities. And there are 3 Pythagorean identities. You only have to memorize this one in blue that I wrote on the right here. But I know I can get to 1 plus tangent squared of x, or tangent squared of x plus 1, if I do something to this one, and that's if I divide by cosine, because, cosine squared of x. Because I know sine over cosine is tangent, and cosine over cosine is 1, so this left side becomes tangent squared of x plus 1. And so that's the first thing I'm going to do, is I'm going to change that, you see that right there, I'm going to change that into secant squared of x. The next thing I'm going to do is I know secant squared of x is really a fraction. And I'm trying to get the top of my my big fraction here to 1. So I know if I change this into just 1 over cosine squared of x, I can move it out in front like this. That's perfectly fine. And look, I now have a 1 on the top. We'll see if the denominator works out, but that's the step I want to do. And when you're multiplying, remember that the denominator gets parentheses around it because a fraction bar groups things together. So we're going to put those together, and when I distribute the cosine squared of x to all the denominator there, we get cosine squared of x minus cosine squared of x times tangent squared of x. Oh, just one other comment, you guys. If you ever think you can finish it on your own, I would highly recommend pausing the video and trying that before listening to how I answer it at any point in the explanation process. So this last one, if we rewrite that as sine squared over cosine squared, write everything as sine and cosine, then we notice the cosine squareds divide out, and we are left with cosine squared minus sine squared of x, and that's what we wanted. The really tricky thing I think here was figuring out that secant squared of x can be written as secant squared in the front, and then also that can be written as 1 over cosine squared of x. Honestly, that was because I knew I wanted 1 in the numerator, and I was trying to think of how can I get rid of the 1 plus tangent squared on top. It just doesn't seem like it should disappear or go anywhere. But secant squared of x becomes 1 over cosine squared of x, and from there on it works out pretty nicely. The next problem I want to do for you is problem number 7. And for this one, I chose this one because the first way I thought of doing it was actually not the simplest, not the most straightforward. And so the other way I thought of, I want to share that with you guys. But again, all these problems, there's more than one way to do this. And often it's the bizarre long ways that are really neat ways, in addition to the quick, elegant ways that are short. So first thing I'm going to do is I'm going to do a common denominator here. That's how I think most of us would approach the problem. And when I first thought of that, I didn't think it would work. But when I started writing it out, I realized, hey, that will work. So we get the denominator 1 minus cosine of x times sine of x. And I'm not going to multiply that out, mostly because I don't think that's going to take us anywhere. You know, cosine x times sine x just looks kind of ugly. And I'm going to leave that separate for now. The numerator, you actually get sine squared of x on the right, and we're going to add that to 1 minus cosine of x squared. Well, I'm going to go ahead and multiply that out because I think something neat might happen there, and if you look closely, you notice, there's a cosine squared of x plus sine squared of x. I know that's equal to 1. So I kind of thought ahead and thought, if we multiply those out, that will become something nice, and that's what you kind of want to look in advance for things like that. So we change that to 1, and we want to simplify this because 1 plus 1 is 2. And I'm looking here and I'm going, that's really similar to the 1 minus cosine of x. Let's factor out a 2 and see what happens. And sure enough, we have 1 minus cosine of x on the numerator and the denominator. And those can divide out. If you're wondering why can those not divide out, and you're stuck on how I got upset at people for dividing out the wrong time, remember that you can, if you can rewrite it as a separate fraction, and indeed because it's all multiplication on the top and the bottom, you can write that as 1 minus cosine of x over 1 minus cosine of x. So those divide out, and we get 2 times 1 over sine of x You guys know 1 over sine of x is cosecant of x, so we are good. Again, here I think the most difficult thing was how do we start approaching it, but if you start kind of the usual method right here, find a common denominator, that'll work just fine. The other thing I thought of, just real quick, is 1 minus cosine of x is, you can't replace that with sine. Kind of like you can replace 1 minus cosine squared of x, you can replace that with sine squared. So I knew, what if we multiply that by 1 plus cosine of x? It was called the conjugate. I think it's a little bit messier, but I believe it does work. And you're only multiplying the right fraction because you'll get a common denominator of sine squared, and that will lead to, should lead to the exact same answer. So if you want to try that, that would be a good adventure. For this last problem, what we want to do, I chose this one because it was one that was not immediately obvious, and we're going to actually use a strategy that you can use. So just a reminder of a few of the rules. Remember, we can only work with one side. I think if we could multiply something by both sides of this equation, it would make this problem a lot easier. And it's one of the challenges of this. We can't multiply by both sides. And remind me to show you in class, if I haven't yet, why we can't do that. Another thing is you want to pick the more complicated side. Well, these two sides are basically symmetrical, so it doesn't matter which side you pick, it's going to be equally difficult. So I'm going to start with the left side because, hey, it's the left side. You can honestly start with either side. And the numerator there, I'm going to change that. Let's see here. First, I changed that to cosine of x over sine of x because that's cotangent. And I'm going to go ahead and change 1 into sine over sine because I want a common denominator on top so I can combine some things and simplify some stuff. On the denominator, I'm going to do the same thing. So it's exactly the same thing with the exception of that you have addition instead of subtraction there. And then what I'm going to do is I'm going to add those fractions, or subtract them in the case of the numerator, and you get sine of x over sine of x. At this point, I'm kind of stuck because I just don't see how this is going to get us to tangent of x. So what I'm going to do here, oh, by the way, you could divide those signs out. If you're struggling with y, can you divide those signs out? What you should do is you should remember you can multiply by the reciprocal, and it's a few more steps of writing it down, but you should definitely recognize where that comes from instead of just assuming that I'm right. So here is the new strategy I want to show you guys is instead of just being stuck here on the left side, and instead of cheating and just, multiplying by the right side or doing something like that, I'm going to kind of bend the rules. And it's not really bending the rules, it's more thinking ahead on the right side. I know I want to make turn the left side into the right side, but what I could do is I could kind of work backwards with the right side and see, is there like a common point that I can get to turn it into the right side? So notice I'm going to write all this in a cloud because it's kind of, I'd say it's sort of happening in my head, but that's kind of a lie. It's kind of happening on the paper, but this is not actually a part of my proof, okay? So what I'm going to do is I'm going to change this into sine over cosine, very much the same way that I changed the left side into cosine over sine. And those ones, I'm going to change those into cosine over cosine. That way I can add common denominators. Now notice the symmetry of these two problems. First of all, I think it's pretty awesome how math works out and how cool that is that these two sides are actually equal. But also notice I'm just doing the exact same thing on the right, just with the kind of the co-function, right? So I'm using sine where cosine was and cosine where sine was. And it doesn't always work out that way, but let's explore a little bit and see what happens here. Well, when I combine like terms, I'm dividing by cosine, and look, I could divide by the cosines there. Well, look at that. When I divide out those cosines, I get to the exact same equation as I had, or the exact same expression I had in the blue on the left over there. So I know if I just multiply by the correct thing, I can get over to the red. So let's do this. First of all, I'm going to rewrite the blue. So that's what we have, cosine of x minus sine of x divided by cosine of x plus sine of x, and that's kind of where I'm stuck. But I notice on the red in my green cloud or bubble over there, I thought I need to divide out the cosines. So what if I multiplied by 1 over cosine on the numerator and denominator? That's multiplying by 1, so I'm allowed to do that. And what that's going to do is that's going to turn it into the function that I have here. Do you notice how I just got the equation now on the right. And hold on, I noticed I had an error. That should not be sine, that should be cosine, because I want it to be, let's see here, cosine. I got too excited. Multiply by 1 over cosine. There we go. And that now becomes the bottom equation in the cloud. Okay? So working out from here, I'm now going to separate the fractions. I can do that. And when I do that, I get 1 minus tangent of x divided by 1 plus tangent of x. So notice one thing. I was always working with the left side of the equation over here, okay, in my final proof. But I thought ahead on the right side, and that's perfectly allowed. That's completely okay to kind of figure out, okay, where does my work need to go? This, I would say, is the most advanced, most difficult, and last approach to these kinds of problems that you need to learn before you kind of know all the tricks. Once you're getting to the point where you can work ahead on the other side and still figure out how to solve it just using one side, that's kind of the proof that you have, you've made it, okay? So, don't worry if this problem was difficult. Try a handful more and we'll do more in class. Thank you for watching.